Hola, mi clase.
All right, we're doing 6-4. Today we are going to describe a relationship given a graph, and we're going to work on sketching graphs given a description. So there's no key terms because everything is the same as that we've talked about. Slope, y-intercept, initial value, rate of change, all of that's the same. So if you notice, this is similar to our turtle activity that we did on Desmos the other day. So we have this roller coaster park, so like Disneyland, Knott's Berry Farm, Six Flags, and it's open May to October each year. And it says the graph shows the number of park visitors over its season. So these are each the sections. So they have this section, this, right? So this tells us things about the graph, right? So we could say, section 1, no change in visitors. Because see how it's flat? There's no change. Okay, so the rate of change is what we would say it's 0, right? Section 2, there's an increase. It's a steady increase. See how it's the same? It's pretty quick too, right? So steady increase. We can even say rate of change. It's quick because of how steep it is, right? / steep. Section 3, we could say it's slowing, rate of change is slowing. Right? It's still increasing, but it's slowing down. Section 4. Section 4, there's a decrease in rate of change. And then section 5. Why don't you write something for section 5? What do you think? So here's what, we said rate of change for section 1 is nothing. There's 2 is a steady increase. It's quick and steep, okay? So you can kind of use these. So I want you to write what you would say for section 5 based off what we did for each of the other sections. Oh, I cut off part of this. I apologize. It says Grace, Jet, Mike are studying words for a spelling bee. We were given 3 of them, Grace, Jet, and Mike. We have 3 graphs. And so what we're going to do is match the graphs to the situations. So Grace starts by learning how to spell many words each day, but then learn fewer and fewer words each day. Jet learned how to spell the same number of words each day. Mike started by learning how to spell only a few words each day, but then learned a greater number of words each day. So if we look, we've had the number of days across the X's and the number of words learned across the Y's. So if we look at Grace's, it says that she started to learn lots of words each day. Then she learned fewer and fewer as the words each day. So this means it's pretty steep, right? Lots and lots and lots of words, so high number, but then less and less and less and less. And this also means that her rate changed, right? It wasn't steady because it was first a lot of words and then not very many words. So we want to look for a graph that has a lot of words, but then slowly goes down, right? So these are the 2 that change. If you look here, here's where this is not a lot of words, right? We're not very high on here, but then it jumps really fast. So that's not what Grace's did, right? She learned a lot of words really fast, but then slowed down. So here you can see this gap is a little bit less, where here she's already up at, 50 words by day 2. So this is Grace's because her initial rate is very quick, lots and lots and lots of words, but then it slows down. okay? So then we have Jet. Jet learned the same number of words each day. So this is our steady rate, same number of words each day. So if we have the same thing happening every day, that's going to be our linear relationship, right? Because that's what a linear relationship does. It has a constant rate. And then that does leave this last one, this middle one, to Mike. But if we look at Mike's, it says only a few words, so slow rate, few words to lots of words. And so that's why Mike starts way down here and then jumps really fast. Okay, and again, it's also the one that changes, so that's why it curves like that, because it's not a constant rate. Oh, cut this off too. So we're going to sketch a graph for a situation. So it says Mrs. Sutton provides free math tutoring to her students every day after school. No one comes to tutoring sessions during the first week of school. Over the next 2 weeks, use of tutoring service gradually increases. Okay, so we got to draw a little graph. Okay, so crossed here is going to be our weeks. We can even put some tally marks, 1, 2, 3, 4, 5, 6. Maybe put there 1 there so it's a little more even. And then this would be the number of students. Now we don't have to actually put numbers for the number of students because we don't know, it doesn't say. You know, maybe for the weeks we can, because we do know it does say first week, second, you know, next 2 weeks. So we do know there's some numbers in there, so we can definitely put some here. Okay, if you notice, I'm going to go back for a second. If you notice, the graph here doesn't say days and numbers either. And our first graph did not say which month it was, and it didn't say how many. And so with these kinds of situations, we don't have to have a perfect number, okay? So it does say that for Mrs. Sutton's math tutoring, no one came. Now, no one coming does mean 0. And it does say for the first week. So we kind of need to, I'm going to use a different color so we can see it. But you guys would need to kind of color this line in a little thicker. Make this line right here a little thicker from 0 to 1. Okay, so remember from our very first example, this section 1 being flat meant there was no change, meaning our rate of change was 0. If no one shows up, then we're not increasing or decreasing. So that's why it's going to start here. Then it says that after the first week, over the next 2 weeks, the use of the tutoring service gradually increases. So from here and on, it's going to go up. Okay, and it's not steep, it just is gradual, so we don't have, I mean, we could even do this. Okay, right here, let me delete my first one. So over the next 2 weeks, it gradually increases. Now, we don't know how long she does it for, we don't know how high it goes up, so that would be just fine. We can kind of just stop, we don't have an idea, but at least it gives us an idea of this information. Okay, there it is, there's our graph. Nothing crazy to it. All right. In a lab environment, colonies of bacteria follow a predictable pattern of growth. The graph shows the growth over time. Okay, so it doesn't tell us what kind of time, seconds, minutes, days. And it does say this is the number of bacteria, they call them microorbs, but it doesn't say what the number is. Okay, and then it splits them into phases for us, kind of like the roller coaster split it into that we could clearly see sections, right? They put numbers for us, 1, 2, 3, 4, same idea. So it says, what is happening to the population during phase 2? So if we look at phase 2, this is it right here. There is a very quick change in rate, right? This is very steep. So when it's very steep, it means it has a high rate of change. It's also a very quick change from phase 1. Okay, so phase 1 was very low and then it just very quickly changed, right? But this is a very high rate of change because that's why it's very, very steep. All right, so then it says 2, what is happening to the population during phase 4? All right, here's phase 4, it's going down. So we would say that's at a decrease in rate of change. You could also say the population is decreasing, right? Because it's clearly going down from where it just was. All right, I'm going to add a question 3. I'm going to say what is happening. Actually, I'll type it for you guys just so it's a little bit better. Handwriting, hold on. So we're going to say what is happening to the population during phase 3. So I'm going to add that question and I want you guys to answer it. Okay, so what could we say about the population in phase 3? That's this phase right here. Okay. So here is some more matching. So the graph shows the speed of 3 people who are riding snowmobiles. Tell which graph corresponds to each situation. So we've got graph 1, graph 2, graph 3. Okay. Remember, a flat spot means that there's no rate of change. It's like a 0, no rate. And then remember, down means it's a decrease, so a negative rate of change, and an increase is a positive rate of change. So it says Chip begins his ride slowly, but then stops to talk with some friends. After a few minutes, he continues his ride, gradually increasing his speed. Okay, so Chip begins his ride slowly, but then stops to talk with some friends. After a few minutes, he continues his ride, gradually increasing his speed. So we're looking for something that increases, at some point stops, and then increases again. So if we look, the first one increases, and then the speed just flatlines. Okay, so there's no change in that speed. They're still going though, right? There still is a speed right here, right? They're still at a speed, but they just are now at this flat speed. This one increases, slow down, no speed. See how we're at 0 speed, and then we increase again. And graph 3 increases and then decreases, and then we don't know what happens after that. So we again are looking for an increase, a no speed, stop, and then an increase again. So this is our Chip, because Chip, to come stop and talk to his friends, he has to slow down first, right? So he increases, he slows down to stop to talk to his friends for a bit, and then he increases. So Chip is going to be graph 2. All right, 4. Lydia steadily increases her speed through most of the ride, then slows down as she nears some trees. So we're looking for an increase and then a decrease. That's it. Which one has an increase and then a decrease? This is an increase and then a steady pace. They don't change their speed. And this is an increase and then a decrease. So that right there explains Lydia's. She speeds up and then she slows down. That would be graph 3. All right, so things to remember, be specific. Okay, remember this kind of line means increase. This kind of line means decrease. Oops. And this means no change. All right, so we have Paulo. He stood at the top of a diving board. He walked to the end of the board and then dove forward into the water. He plunged down below the surface, then swam straight forward while underwater. Finally, he swam forward and upward to the surface of the water. Draw a graph to represent Paulo's elevation at different distances from the edge of the pool. So this is the edge of the pool. This is how far away he would be from the edge of the pool. This is the water level, okay? This is the water level. So this up here would be above the pool water. This down here would be under the water, right? Above the water, under the water. This is right at the top of the water. All right, you're gonna draw a graph to represent the situation. So it's gonna be similar to what we did here. Okay, you need to draw a graph so it will kind of look, you know, like this. So you're showing Paulo's information. All right, until next time, adios.